Welcome, everyone. In today's session, we're going to put theory into practice. You know, it's one thing to learn the definitions, but it's another to actually see them work. So we're going to dive into two detailed case studies to understand exactly how object-oriented programming concepts, things like inheritance, abstract classes, and interfaces, are used to build solutions for real-world problems. Ready to get started? Let's jump right in.
So here's what we have planned for today. First, we'll quickly touch on why case studies are such a great way to learn. Then we'll get into our first big example, the bicycle shop. We'll break down the requirements, then build the Java code for it piece by piece. After that, we'll take everything we learned and apply it to a second case study, a beverage machine, to really solidify those concepts. And to finish up, we'll do a quick summary and even look at some potential exam questions to make sure you're feeling confident.
All right, so why are we starting with case studies? Well, because programming is all about application, right? It's not enough to just memorize what an abstract class is from a textbook. The real skill is knowing when to use one and why it makes your code better, more efficient, and more logical. These examples are going to be that bridge between knowing the definition and knowing how to use the tool.
And this right here, this is our main goal for this session. This is the key takeaway. By the time we're done, you should be able to look at a problem description, just a paragraph of text, and feel confident that you can map that out and turn it into a working object-oriented program from scratch. අද දේශනේ අවසානයේදී ඔයාලට තියෙන්න ඕන ප්‍රධානම හැකියාව තමයි මේ. ඔයාලට යම්කිසි ගැටලුවක් problem description එකක් දුන්නම ඒකට විසඳුමක් විදියට සම්පූර්ණ object-oriented programming program එකක්. ඒ කියන්නේ ඌ program එකක් මුල ඉඳන්ම සැලසුම් කරලා ලියන්න පුළුවන් වෙන්න ඕන. අපි මේ case studies දෙකෙන් ඉගෙන ගන්නේ ඒකට අවශ්‍ය කරන තාක්ෂණික ක්‍රම සහ හිතන විදියයි.
Okay, let's get into our first case study. We're going to simulate a bicycle shop. Now remember, the most critical first step in any software project is making sure you really truly understand the requirements. So let's take a look at what our bicycle shop actually needs to do.
Okay, think of this slide as a map that will help us build our classes. Right away, we see two main types, motor and foot bicycles. This should immediately make you think of a parent bicycle class with two children. Then, foot bicycles are broken down further into adult and kids. That's another layer of inheritance right there. Now look at the features. All bicycle have a color, so that's a perfect property for our base bicycle class. But unique things like an engine number for motor bicycles or stabilizers for kids bicycles help us decide which properties go into which specific child class.
We've got our requirements locked down, so let's start translating them into actual Java code. We're going to begin by building the main hierarchy for the bicycles themselves, and for that, we'll use one of the core pillars of OOP, inheritance. Here we go. This is our foundation, the bicycle class. The first keyword to notice is abstract. This is important. It means you can't create an object of this class directly. It's not a real thing. It's a blueprint. Inside, we have private string color, which enforces our rule that every bicycle must have a color. And the constructor is just there to initialize it. That line, this.color equals color, is simply saying, take the color that was passed in and assign it to this object's color variable.
හරි මේ තියෙන අපි ප්‍රෝග්‍රෑම් එකේ අතිවාරම බයිසිකල් ක්ලාස් එක. මුලින්ම බලන්න abstract කියන keyword එක. අපි ඒ ගැන ඊළඟ slide එකේදී ගැඹුරෙන් කතා කරමු. ක්ලාස් එකේ ඇතුලේ private string color කියලා variable එකක් තියෙනවා. මේක private කරලා තියෙන්නේ encapsulation කියන concept එක නිසා. ඒ කියන්නේ මේ color කියන variable එකට පිටින් කෙලින්ම access කරන්න බෑ. Public bicycle string color කියන්නේ constructor එක. this.color equals color කියන පේලියෙන් කරන්නේ constructor එකට parameter එකකට විතර එන color අගේ ඒ මොහොතේ හදන object එකේ color කියන instance variable එකට දාන එක. this කියන keyword එකෙන් කියන්නේ මේ object එකේ කියන එක. ඒකෙන් program එක දන්නවා අපි කතා කරන්නේ class එකට අයිති variable එක ගැනද නැත්නම් constructor එකට ආපු parameter එක ගැනද කියලා.
So, what exactly does abstract mean? Well, think of an abstract class as a blueprint you can't build from directly. You can't just write new bicycle. Its whole purpose is to be extended by other more specific classes, giving them a common starting point. This is fantastic because it lets us enforce rules. By making bicycle abstract, we're basically saying, hey, if you're going to use my code, you have to create a specific kind of bicycle, which helps prevent a lot of potential errors down the line.
So what exactly does abstract mean? Well, think of an abstract class as a blueprint you can't build from directly. You can't just write new bicycle. Its whole purpose is to be extended by other more specific classes, giving them a common starting point. This is fantastic because it lets us enforce rules. By making bicycle abstract, we're basically saying, hey, if you're going to use my code, you have to create a specific kind of bicycle, which helps prevent a lot of potential errors down the line.
Okay, now let's get into a specific, concrete class, motor bicycle. That little phrase, extends bicycle, is powerful. It means a motor bicycle quite literally is a bicycle. The line super color is how we call the parent's constructor to handle setting the color. And to get a unique engine number, we use a private static ent. The static keyword is the magic here. It means this variable belongs to the motor bicycle class as a whole, not to any single object. So every time a new motor bicycle is made, this counter goes up, guaranteeing a unique number for each one.
හරි. දැන් අපි නිශ්චිත ක්ලාස් එකක් බලමු. motor bicycle. Public class motor bicycle extends bicycle කියන පේලියෙන් කියවෙන්නේ motor bicycle කියන්නේ bicycle class එකෙන් පැවතෙන child class එකක් කියන එක. constructor එක ඇතුලේ super color කියන්නේ parent class එකේ constructor එක call කරලා color එක set කරනවා. private static int number of motor bicycles කියන variable එක static නිසා ඒක class එකටම පොදුයි. ඒක හරියට මුළු කණ්ඩායමටම class තියෙන එක ලකුණු පුවරුවක් වගේ. හැම ඔබ්ජෙක්ට් එකක්ම player හැදෙනකොට ඒ ලකුණු පුවරුව එකකින් වැඩි වෙනවා. ඒ නිසා හැම motor bicycle එකටම unique engine අංකයක් ලැබෙන එක සහතික වෙනවා.
Next up, we have the foot bicycle class. And notice, it's also abstract. Why do you think that is? Well, because our shop doesn't just sell a generic foot bicycle, right? It sells specific types, adult and kids. So this class acts as a kind of middle manager, an intermediate blueprint. It extends bicycle so it gets the color property, and it adds the bell attribute which is common to all foot-powered bikes. And here we have our final concrete classes. Both kids bicycle and adult bicycle extend foot bicycle. Now think about what that means. They get everything from foot bicycle, which in turn got everything from bicycle. So when you create a kid's bicycle object, it's going to have a color, a bell, and then its own special property, stabilizers. In the same way, the adult bicycle gets the color and bell, and then adds its unique lamp. See how the hierarchy builds up? Metinape inheritance yuhi avasana matama. Kids bicycle saha adult bicycle kina dekama concrete classes. Ikan napida me class waling kilinma objects hada napulon. Me class dekama extends foot bicycle karanoa. Ikan bicycle classican in a color ekat. Foot bicycle classican in a belekat me dekatama urmowenawa. Ikenne kids bicycle object ekak haduama ekatule color, bell saha ekatama avenika stabilizers kina properties tunama tiyanawa. E vidhetama adult bicycle classicat color saha bell uruma karagina ekatama avenika lamp kina property eka ekatu karagannowa.
All right, time to add another layer of complexity. Our shop doesn't just have products, it has processes. We have two divisions, assemble and quality check. The assemble division is responsible for creating the bicycles. But then there's a business rule. Only motor and kids bicycles need a quality check. And that check involves calling a special method called getQuality. But hang on, we haven't defined that method anywhere yet. This is a clue that we're going to need a new tool to handle this.
So, just like we made a base class for bicycle, it makes sense to create a base division class. We are making it abstract for the same reason, because there are only specific name divisions in our shop. It has one common property, a private string name, which gets set in the constructor. This is a great way to ensure that any division we ever create in the future absolutely must have a name.
අපු බයිසිකල් වලට පොදු බේස් ක්ලාස් එකක් හැදුවා වගේම ඩිවිෂන්ස් වලටත් පොදු ඩිවිෂන් කියලා බේස් ක්ලාස් එකක් හදනවා. මේකත් ඇබ්ස්ට්‍රැක්ට් ක්ලාස් එකක්. මොකද අපේ ෂොප් එකේ තියෙන assemble, quality check වගේ නිශ්චිත ඩිවිෂන්ස් මේ ක්ලාස් එකේ තියෙන හැම ඩිවිෂන් එකටම පොදු ප්‍රොපර්ටි එකක් private string name. කන්ස්ට්‍රක්ටර් එකෙන් මේ නම සෙට් කරනවා. මේ නිසා අපි හදන ඕනෑම ඩිවිෂන් එකකට නමක් තියෙන එක අනිවාර්ය වෙනවා.
Now let's look at our assemble division. Take a close look at the assemble method. It uses a simple if-else-if block to decide which type of bicycle object to create based on a string input. This is a really common and useful design pattern called a factory pattern. The idea is to centralize the logic for creating objects in one single place. It makes your code so much cleaner and way easier to manage later on.
මිතිනේ assemble division එක assemble method එක බලන්න ඒක input එකක් විදිහට string එකක් අරගෙන if else if block එකක් පාවිච්චි කරලා අදාළ bicycle object එක හදනවා. මේ විදිහට input එකක් මත පදනම්ව වෙනත් objects හදන වගකීම එක class එකට පවරන design එකට අපි කියනවා factory pattern කියලා. මේකෙන් object හදන logic එක එක තැනකට ගේන නිසා code එක පිළිවෙලකට තියාගන්න සහ පසුව වෙනස්කම් කරන්න හරිම ලේසි.
Next up, the quality check division. And its check quality method is super interesting. Look at the parameter type it accepts. Checkable QC bicycle. It doesn't say motor bicycle. It doesn't say kids bicycle. It says checkable. This is a type we haven't defined as a class. So what is it? This is our introduction to interfaces. The method simply trusts that whatever object it receives of type checkable, it will definitely have a getQuality method it can call.
ඊළඟට quality check division class එක. මේකේ තියෙන check quality method එකේ parameter එකේ type එක දිහා බලන්න checkable QC bicycle. එතන motor bicycle කියලාවත් kids bicycle කියලාත් නැහැ. තියෙන checkable කියලා. මේක class එකක් නෙවෙයි. මෙතනින් තමයි අපි interfaces කියන concept එකට එන්නේ. method එක ඇතුලේ කරන්නේ qcbicycle.getQuality කියන method එක call කරන එක විතරයි. මේක වැඩ කරන්නේ checkable කියන type එකේ object එකක් ආවොත් ඒකේ අනිවාර්යයෙන්ම getQuality කියන method එකක් තියෙනවා කියලා මේ division එක දන්න නිසායි.
And here it is, public interface checkable. So an interface isn't a class, it's a contract. It's a set of rules. It just declares methods. It doesn't provide the code for them. This interface basically says, look, any class out there that wants to be considered checkable absolutely must provide a public method called getQuality that returns a Boolean. It's a promise that a certain capability exists.
So let's put a formal definition on that. An interface is essentially a contract of behaviors. When a class implements an interface, it's making a promise that it will provide the code for all the methods defined in that interface. This is incredibly powerful because remember, a class can only extend one parent class, but it can implement many interfaces. It's like gaining multiple different skill sets. Singalagi, api eka tavatikak vidamatva balamu. Class sekak interface sekak implements korona kyanne ara givusumada atsan koronawa vage verak. Meka harima balavat concept tekak, mokada class sekaka extends karanna puluwan eka parent class ekak vitarai. Eka hariyata oyata inda puluwan ekama jiva vide matva demo pian dennek vage. Habai, interface kipyak implements karanna puluwan eka hariyata oyata vivida hekyawan skills kipyak igenaganna puluwan vage. Oyata ekapara chitra andinnat, sindukhyannat, program koronat puluwan. Evage class ekakadat, checkable vennat, sellable vennat, repairable vennat puluwan.
This is a classic question you'll see on exams, so let's make it crystal clear. You use an abstract class for an is-a relationship. It's about identity. A motor bicycle is a bicycle. You use an interface for a can-do capability. It's about behavior. A motor bicycle can be checked. This allows completely unrelated classes to share a common function, which is incredibly flexible. Sinhala, මේක විභාගවලට නිතරම අහන ප්‍රශ්නයක්. ඒ නිසා අපි මේක පැහැදිලිවම තීරුම් ගමු. Abstract class එකක් අපි පාවිච්චි කරන්නේ is-a සම්බන්ධතාවයකදී. ඒ කියන්නේ එක දෙයක් තව දෙයක වර්ගයක් වෙනකොට. උදාහරණයක් විදියට a motor bicycle is a bicycle. මේකෙන් object එකක මූලික අරන්නතාවය identity කියවෙනවා. Interface එකක් අපි පාවිච්චි කරන්නේ can do කියන හැකියාවක් දක්වන්න. Motor bicycle එකක් check කරන්න පුළුවන්. Can be checked. Interface එකෙන් object එකක් කියන්නේ මොකක්ද කියලා නෙවෙයි කියන්නේ. ඒ object එකට කරන්න පුළුවන් දේ මොකක්ද කියලා.
So to make good on that contract, we need to update our classes. Take a look at the motor bicycle class declaration now. Public class motor bicycle extends bicycle implements checkable. It's doing both. It's extending its parent and implementing the interface. And because it signed that checkable contract, it is now forced to provide the code for the getQuality method. The add override annotation is just a good practice to tell the compiler, yes, I am intentionally implementing this method from the interface. And we do the exact same thing for the kids bicycle. Hari, then api checkable gusuma sampurna karanna api class tika update karamu. Motor bicycle class ke declaration ek balanna. Public class motor bicycle extends bicycle implements checkable. Ekane ek bicycle class ek extend benol bage me checkable interface ek implement karanwa. Checkable contract ek atsan karpunissa ek anivaryamma getQuality method ek hadanna ona. Add override ken annotation ek pavichi karane eken compiler ekකට keno api parent class ekaka hari interface ekaka hari thena method ekak nawata implement karanwa kiyala. Kids bicycle class ekatak wenne ekamai.
Okay, we are almost done with the logic. Just two final requirements to tie it all together. First, the shop needs to keep a record of every quality check. For this, we'll use a hash map to store pairs of data, the bicycle object itself and the Boolean result of its check. Second, the system needs to be interactive. It has to listen for user input from the console to actually kick off an order.
This bicycle shop class is like the brain of the operation. It's the central controller. You can see it has an assemble division, a quality check division, and our hash map. The accept order method is where the magic happens. It tells the assembly division to make the bike, and then, this is the important part, it uses instance of checkable to ask, does this new object I just got implement the checkable interface? If the answer is yes, then it gets passed along for a quality check. Let's just trace that flow one more time, step by step. 1. The bicycle shop gets an order. 2. It delegates the creation to the assemble division. 3. A brand new bicycle object is created and returned. 4. The crucial instance of checkable check happens. If it's a motor bicycle, this is true. 5. The object is passed to the quality check division. This right here is polymorphism in action. The method accepts any checkable object, not just one specific type. And finally, 6. The result gets stored in our hash map.
And finally, we have our demo class, which contains the main method. This is the entry point for our entire application. All it does is create one bicycle shop object and then enter an infinite while true loop to keep listening for commands. It uses a scanner to read input from the user. If that input starts with 0, it grabs the rest of the string as the bicycle type and passes it to our shop.acceptOrder method, which kicks off that whole process we just walked through.
Excellent work. We've built a whole system. Now, let's lock in those concepts with a second case study, a beverage machine. As we go through these new requirements, I want you to actively look for the patterns. See if you can spot where we'll need abstract classes, specific child classes, and where an interface might come in handy.
Okay, let's break down this new problem. The machine makes tea, coffee, and water. That sounds like a class hierarchy. Every cup gets a unique ID, just like the engine number. Now, this is a huge clue. Tea and coffee must be tracked in a single array list. To store different types of objects in the same list, they have to share a common parent or, more likely, a common interface. And finally, only tea and coffee have calories that can be checked. That sounds like another special capability, doesn't it?
The user interaction is spelled out for us here. An input of 0 followed by a beverage name produces that drink. An input of 1 checks the calories of the last beverage made, and an input of 2 tells us the total count of tea and coffee cups produced so far. This gives us a really clear structure for the logic inside our main program loop. Sinhala, userat kaganodinu karnavidie methana pahavilewama dilatinawa. 0 beverage name kela input karot, machinik and abimiat hadanona. 1 kela input karot, umtilahadapu bimia calorie gana print karnana ona. 2 kela input karot, metek hadapu tea saha coffee cup ganane ekatua print karnana ona. Maken apit apide kabe program eke main loop eke logic eke hadagana poluan.
All right, the requirements are clear. Let's jump into the Java code. And as we do, just notice how the same patterns we learned from the bicycle shop are going to show up here again. That's the beauty of design patterns.
Just like bicycle, we start with an abstract base class, beverage cup. It handles the unique ID generation using a static counter. Same pattern as before. But look at this. It also has an abstract method, public abstract string, getCupType. An abstract method is a method with no code inside. This is a powerful way to force any child class that extends beverage cup to provide its own implementation, guaranteeing that every type of beverage will know how to identify itself. Si Heliana, bicycle class එක වගේම මෙතනත් අපිට abstract base class එකක් තියෙනවා, beverage cup. Unique ID එක හදන්නේ static variable එකකින්, හරියටම motor bicycle උදාහරණය වගේමයි. ඒ වගේම මේකේ abstract method එකක් තියෙනවා, public abstract string getCupType. Abstract method එකකට body එකක්, ඒ කියන්නේ කෙරි ඇතුලේ code එකක් නෑ. මේකෙන් වෙන්නේ beverage cup class එක extend කරන්න ඕනෑම concrete child class එකක් මේ getCupType method එකට අදාළ code එක අනිවාර්යයෙන්ම ලියන්න ඕන වෙන එක. මේකෙන් අපි සහතික කරනවා හැම බීම වර්ගයකටම තමන්ගේ නම කියන්න පුළුවන් වෙන විදිහක් තියෙනවා කියලා.
There's a lot on this slide, so let's walk through it. We've defined a new checkable interface, this time with a check calorie method. Then we have our 3 concrete classes. Coffee cup and tea cup both extend beverage cup and implements checkable. But look at water cup. It only extends beverage cup. It does not implement the interface. This is a perfect demonstration of how to selectively apply capabilities to only the classes that need them, which keeps our code clean and logical. Here's the controller, the beverage machine. Now, pay close attention to its instance variable, array list of checkable calorie drinks. The list is of type checkable, not beverage cup. This is how we enforce our rule. It means we can only add objects that have implemented the checkable interface to this list. This guarantees that only tea and coffee cups are tracked. The produce beverage method then works like our factory, creating the drinks and adding the right ones to this list. Metianne beverage machine classica. Eke instance variable ekabalanna, array list of checkable calorie drinks. Make a harima vedakat. List eka type eka checkable. ඒ කියන්නේ අපිට මේ ලිස්ට් එකට දාන්න පුළුවන් checkable interface එක implement කරපු objects විතරයි. tea සහ coffee විතරක් track කරන්න ඕනේ කියන rule එක අපි implement කරන්නේ මෙහෙම තමයි. produce beverage method එකේදී coffee හරි tea හරි හදද්දී ඒ object එක calorie drinks list එකට add කරනවා. water හදද්දී ඒක list එකට add කරන්නේ නැහැ.
And for the final piece, the demo class. If the user types 1, we first check if the last beverage, B, is an instance of coffee cup or an instance of teacup. Only if that's true do we then cast it to checkable and pass it to the getCalories method. Why do we need that extra cast? Because the variable B is of type beverage cup, so the compiler itself doesn't know for sure if it has a checkCalorie method. The cast is us telling the compiler, don't worry, I've already checked, I promise this object is checkable.
Sinhala. අවසාන වශයෙන් beverage machine එකේ demo class එක. input එක 1 නම් මුලින්ම check කරනවා අන්තිමට හදපු B object එක instance of coffee cup ද නැත්නම් instance of tea cup ද කියලා. එහෙම නම් විතරක් ඒක checkable type එකට cast කරනවා. ඒ කියන්නේ type එක මාරු කරනවා. ඇයි මේ cast එක අවශ්‍ය? මොකද B කියන variable එකේ type එක beverage cup. beverage cup class එකේ check calorie කියලා method එකක් නැහැ. ඉතින් compiler එක දන්නේ නැහැ B object එකට මේ method එක call කරන්න පුළුවන්ද කියලා. cast කරලා අපි compiler එකට කියනවා බය වෙන්න එපා මං instance of වලින් check කරලා ඉවරයි මේක අනිවාර්යෙන්ම checkable එකක් ඒ නිසා ඔයාලට getCalories method එක call කරන්න පුළුවන් කියලා.
Wow, we have covered a lot of ground today by building two complete, albeit simple, systems from scratch. So let's take a moment to pull it all together, consolidate what we've learned, and get you ready for any exams.
Okay, so let's do a quick, high-level recap. Today we looked at 2 case studies to see how core OOP concepts, inheritance, abstract classes, and interfaces aren't just theory. They are practical tools we use to model real-world problems, helping us build software that's flexible, logical, and easy to maintain.
හරි අපි අද දේශනෙන් ඉගෙන ගත්ත දේවල් සරලව සාරාංශ කරගමු. අපි case studies දෙකක් ඒ කියන්නේ bicycle කඩයක් සහ බීම හදන machine එකක් ගැන කතා කළා. මේ උදාහරණ දෙකෙන්ම අපි බැලුවේ object oriented programming වල තියෙන inheritance, abstract classes සහ interfaces කියන සංකල්ප පාවිච්චි කරලා සැබෑ ලෝකයේ තියෙන ප්‍රශ්න වලට code එකකින් විසඳුම හදාන්නේ කොහොමද කියලායි. අපි දැක්කා පොදු දේවල් base class එකට දාලා විශේෂ දේවල් child class වලට දාලා code එක පිළිවෙලකට හදාගන්න විදිය. ඒ වගේම සමහර class වලට විතරක් විශේෂ හැකියාවන් දෙන්න interfaces පාවිච්චි කරන විදියත් ඉගෙන ගත්තා. මේ ක්‍රම පාවිච්චි කරාම අපිට ලේසියෙන් වෙනස්කම් කරන්න පුළුවන් නඩත්තු කරන්න ලේසි නම්‍යශීලී flexible software හදාගන්න පුළුවන් වෙනවා.
If you remember anything from today, make it these 5 concepts. Inheritance is that is-a relationship. An abstract class is a blueprint used for sharing common code and identity. An interface is a can-do contract for behavior. Polymorphism is the ability to treat different objects through one common type, like our checkable variable. And finally, composition is the has-a relationship. Our bicycle shop has an assembled division.
Now, to really test your understanding, think about questions like these. First, abstract class versus interface. The key is a versus can do. A motor bicycle is a bicycle, abstract class, but it can be checked, interface. Second, polymorphism. The best example is the quality check divisions method that accepted a generic checkable type, not a specific bicycle. And third, a modification question. To add hot chocolate, you'd simply create a new hot chocolate class that extends beverage cup and implements checkable. And then you just update the factory method in the beverage machine.
Let's end with a formal definition of polymorphism because it's so important. The word itself just means many forms. In our code, this meant that a single variable, like QC bicycle, could hold many different forms of objects. One moment, a motor bicycle, the next, a kid's bicycle, as long as they all followed the rules of the checkable contract. This is what makes our code incredibly flexible and powerful.
Polymorphism කියන එකේ සරල තේරුම බහුරූපීතාවය. ඒ කියන්නේ විවිධ ආකාර ගැනීමයි. OOP වලදී මේකෙන් අදහස් වෙන්නේ parent class එකක හරි interface එකක හරි reference variable එකක් පාවිච්චි කරලා child class object එකක් handle කරන්න පුළුවන් වීම. මේ නිසා එකම ක්‍රියාව උදාහරණයක් විදිහට check quality method එක call කරන්න එක විවිධ objects මත විවිධ ආකාරයට ක්‍රියාත්මක කරවන්න පුළුවන්. අපේ උදාහරණයේ quality check division එක checkable කියන එකම type එකෙන් motor bicycle සහ kids bicycle දෙකම handle කළා. ඒක තමයි polymorphism.
And if you ever get stuck trying to remember the difference between all these concepts, especially interfaces and polymorphism, just think of this simple analogy. A USB port on your computer is a perfect real-world interface.
The port itself doesn't know or care if you're plugging in a mouse, a keyboard, or a flash drive. Those are all different classes of devices. But as long as each device implements the interface by having that standard USB plug, the computer knows exactly how to communicate with it through that one common port. That is the power of defining a standard contract. Thanks so much for joining this session today.